Go. So this is the chapter 14 last review day. We've done review before this. If you really want to get the big picture, you're going to have to watch the videos for the last 3 days that I've recorded on this. So let's take a look at this picture. It's kind of informative. It reminds you what the amplitude is. It reminds you what that vertical shift is. I call that the midline right here. And the midline is whatever this number is. That's how much it's shifted up. The period goes from the top to the top, or from the bottom to the bottom. And this one is sine. Now, when we write them, do you remember we always use cosine? If I was going to write an equation for this graph, I would have picked cosine, and I would have said that the x value of the top of the first peak would have been my shift. Because do you get it's been shifted over a little bit, and we could either say it's a shift to the right or the left. We always say to the right. I don't know if you noticed that before, but our shifts are always to the right. Okay, so anyway, when we write these things, they're always cosine. This one is a sine. All right. Let's do our warm-up question. Each of the following are graphs of sine. Which one doesn't belong? As in, they all are different, but is there one that just doesn't fit? Well, I think the question is going to be when it comes to what? Like, this one's different because when it comes to its amplitude, blah, blah, blah. Or you could say this one is different one. This one is different when it comes to the shift. Or this one is different when it comes to whatever. So can you tell me any of these? Oh, like graph 4 is different when it comes to the blank. Yes. Okay, good point. Graph 2 is the only one that hits the y-intercept is at its peak. I like it. The other ones are always somewhere in the middle when they hit the y-intercept. Okay, what's another one that is different than all the other ones because blah? Yes?
Graph 4 is the only one that has an amplitude that's greater than 1.
Graph 4 is different than the others because it has an amplitude, I like it, you just said greater than 1. It looks like the amplitude might be 3. Would you agree with that? Because every 2 boxes is like 1. So here'd be 1. Here's 2. I think the amplitude is 3 there. Whereas the other ones have an amplitude of 1. Yes?
Graph 3 is the only one with a vertical shift.
Graph 3, he's claiming it's the only one with a vertical shift. And I am looking through and I agree with you 100%. This is the only one with a vertical shift. Can you think of any other way where one of them is not like the others? Yes? Graph 1 is like sine except flipped. Because that's where sine would be? Yeah, I think you're right. Okay, any others? Okay, I think that's good enough. I think that helps you graphing from a different kind of an angle. So here's a concept checklist, things you're supposed to know. You're supposed to know what all the parent functions look like. Sine, cosine, tangent, of course, but also cosecant, secant, and cotangent. Would you take a look at these? And tell me, is there any of these you want me to talk about further? Or do you feel like you get the base graphs? Yes?
Less than want to talk about it further, but more when we graph these on the test, if we're graphing like cosecant or secant, is it okay if we graph the parent function as opposite beforehand so we
I agree 100% that I would start, if I was graphing secant, for example, I would start by graphing cosine. And there's part of cosine anyway. I agree 100%. The only thing is, I do ask that when you're done on the test, that you would erase out the cosine that you started with. So yes, that's very smart to do, but we could say that maybe they did that, but they erased it back out. So you should, if you start by drawing the parent function, like for secant or cosecant, and you would go for secant, you'd do cosine. You start drawing those in, then you erase them back out. What do you think is missing that's annoying me? Asymptotes. The asymptotes. I am going to expect to see asymptotes. The fact that this doesn't have any asymptotes makes me wonder if I'm being extra picky more than like most teachers in the United States. Because I would have thought if I ever made these graphs, I would have put in the asymptotes. But I guess now that I'm thinking about it, if I actually looked at Desmos, for example, it wouldn't have the asymptotes in there. Yes? Good question. If it doesn't specify, you are fine with just doing one period.
And that's true for all of us.
Yes, if they don't specify, you get to just graph one period of it. Any other questions? All right. Imagine for a moment you had to do this one. Now I want to remind you, this one has a phase shift in it, where if you can factor it, you should. If you don't factor that out, you're not going to do this right. Then you have to renumber your x-axis before you shift it. Okay, so obviously this is going to go to 55 and negative 55. That's the easy part. Obviously, sine kind of looks like this. But the renumbering happens before the shifting happens. Right here, this is a critical moment. It is not pi over 3. That is not how far you're going to shift it. Because when you factored out the 2, it has to multiply back in and give you pi over 3. So there needs to be another 2 down here so that when you multiplied by 2, it would cancel off that 2 and give you pi over 3. So it's really pi over 6. Put your hand up if you knew that it was going to be pi over 6 shift. So if this is shifting pi over 6, how far is pi over 6? Well, first off, you would have labeled these with regular. 2 pi, pi over 2. And then I like to back it up and go 1 pi over 2, 2 pi over 2, 3 pi over 2, and 2 pi, which is the same as 4 pi over 2. And then I renumber it because of this 2 here. I go through and multiply everything by a half. And that makes this 1 pi over 4, and that's the key, because I know I'm counting by 1 pi over 4s now. The next would be 2 pi over 4. And yes, that reduces, but I like to just leave it. 2 pi over 4, 3 pi over 4, and 4 pi over 4. And now, how far is pi over 6? Yuck. I would ask myself, what's pi over 6 in degrees? Do you remember that? 30. What's pi over 4 in degrees? 45. Why do you care? Because pi over 4 is our current numbering unit. Each of these marks is 45 degrees, and another 45 degrees, another 45 degrees. And so where would 30 degrees be? I need to shift it to the right Well, if this is 45, I'm going to say that's about 30. Now, how exact is that? It's not very exact, but that's okay. I would understand that if we had given you this one on a test. It seems kind of unlikely to me. More likely would have had you shift it over like pi over 4, some distance that we already knew. But then everything can shift over about so far. My new graph. Approximately the blue one. All right. Everybody try number 2. It's a pretty reasonable test type question. Yes. Yes, technically all the graphs should have arrows, but you'll notice that even in our example problems that we just gave you, they don't always have arrows because usually they're made with a graphing utility which doesn't have the arrows. So even on our test, we might not have the arrows, so we can't really mark you wrong for not having the arrows. But technically, they should all have arrows. Yes? It is going to be on paper, plain old paper. For those that are at home, of course, it won't be on paper. Okay, did you remember the tangent ran in here and generally looked like that? And at about halfway over, you put a mark, and then you say that that's where 1 and -1 are. What do you mean half, Surver? Watch. This is what I mean by halfway over. See, this is about halfway. When it's about halfway over, that's where 1 is. And the dot is about halfway between here and here. And then this is pi over 2, and this is negative pi over 2. Then, I change the 1 to a 2. I change the -1 to a -2. I multiply everything by 1 over that. 1 over pi. 1 over pi. That cleans up. Pi's cancel. This is 1/2. This is -1/2. Is that it? No. One more thing. The negative. Did you remember to flip it? The black one will give you the final answer. Don't renumber this and say that that's -2 and say that that's how you flipped it. You can't make the y-axis numbers be negative on top. That just doesn't make sense anymore. You can't do a flip or a reflection by just changing the numbering. All right, this is one where we're going to get a high and a low, and that's all you need is a low and a high and the time that it happened. As soon as I look at the problem, I start making a wave, and either my wave is going to start with a high spot and then come to a low spot, or it's going to start with a low spot and come to a high spot. Looks like this one, they got a maximum really quick in the experiment. That means to me it started with a high spot, and I would write down the high spot and its coordinates and the low spot and its coordinates. Tommy, where would you say the high spot is at?
15 minutes after.
So 15, comma,
125.
125. And then the low spot.
Me?
Nope, I'm going to get somebody else. Aiden, what's the low, the minimum? How'd you get the 43? I know you were thinking something.
15 plus 28.
Yeah, 28 minutes later, so that means from here over was 28 minutes. And so you took 15 and added 28 and gave you 43. And then comma the low temperature. Excellent. And that was given. Always start by finding a low and a high. Then, the next thing I would do is figure out the period. 28's the common mistake answer. Ishi, can you tell me why it's not 28?
Because that is just one high for one low, whereas the entire.
Excellent. So that's only from the high to the low, and to get a full period, you have to go back up to the high. So you need, what do you think the final answer is for period, Miss Ishi? 56 is the period. And periods are always time. At least we use time. So now I know my period. Now I can write my equation. Y equals blank sine blank. Oh, I've already made a mistake. What's my mistake? I never use sine. Please don't be the person that uses sine by accident. They're called sinusoidals, but we don't use sine. I got 4 boxes. Box 1, 2, 3, and 4. Ray, can you tell me one of them? And what would you start with if you were me?
Since we already determined the period, I would just start with period equals 2 pi over b to find the b term.
Period equals 2 pi over b, and we know the period was 56. So 56 equals 2 pi over b. I've tried to teach you that these two can swap. It's the same as multiplying by b on both sides and then dividing by 56, but it saves you a step. So b is equal to 2 pi over 56. But 56 is an even number. So what do you think the b is?
Pi over 28.
Pi over 28. Nice job. All right, next up. Ryan Shaw, tell me what you would do next. Okay, I'm going to give you a hint. See this dotted line I'm drawing through the middle of it? Yes, that's called the midline. Let's do that, and whatever it is, we'll put here. It's a lot of complicated things you're doing in your head. I can tell you're doing it right, but can you tell us what you're doing? What minus what?
I'll find
The midpoint, yeah. I know, but we got to tell people how to do it. So we take the. Oh, you were going to use the x numbers. Ah, okay. So 125 and 99. How far apart are they? And then let's cut that in half. So then it's 13 to here, and another 13 to here. Now can you tell me what the midline is? You got it. 112 is the midline. And where's that go in box 1, 2, 3, or 4?
4.
Yep. So the 112 goes right here. Johnson, we're only inches away from finding box 1. It would be 13. You are absolutely right. It's this distance from the midline up to the peak. So that's 13. Nice. And last but not least, the shift. Let's take a volunteer for this one, either online or in person.
Is it 15?
How'd you get it?
It's the x value of the highest peak.
Ah, the x value of the highest peak goes in here. Because that is where we wish it would have started at its peak. Because that's what cosine does, is it starts at its peak. And that's 15. It's been shifted over from original that far. That's why that's a 15. Put your virtual or real hand up if you feel like this is in your wheelhouse. You could do this. Okay, good. I'm curious, how many of you are, I'm just going to say it, pretty much done with your lab? Just curious. There's not too many people. Okay. Do you get that tonight would be a genius time to do your lab? Do you get it'll make you review this, which is on the test? And do you get that if you're going to have to spend, let's say, an hour finishing up your lab, it's going to cost you an hour either way. You do the hour now, and it helps you study for the test. You do the hour after the test, it doesn't help you study for the test. You know what I mean? It's going to cost an hour either way. Might as well do it when it's going to help you get ready for the test. Let's get it over with. And then you won't have any homework the night after the test. But for those of you that don't have the time tonight, I understand, then the test is tomorrow. The lab's due the next day. Okay, so if I were you, I'd do them both tonight. Study and get your lab done tonight. So that's a review. It's not everything. It covered a lot though. So there's one last thing that I want to do with you on the review day here, because I know what we're testing you on, and I feel like it would be fair to talk about this once before you take your test. All right, so imagine for a moment. Do you know that when somebody wags their finger at you, you have a natural reaction that's annoying? Did you know that? If somebody's like, "Hey," and they put their hand out, there's a natural human reaction that we don't like being pointed at. Okay, and so anyway, imagine that if we actually analyzed that, it was a distance from your nose. If you're waving your finger in front of your nose, forward, backward, forward, backward, forward, backward, forward, backward. Do you get the sinusoidal equation could be written for that? It could. So I'm going to tell you, what do you really need to write a sinusoid? You need a low and a high, right? This is going to be distant from my nose. My finger is going to start 1 inch from my nose. Then my finger is going to proceed to 17 inches from my nose. Okay, so here's my finger. I'm going to try to just use a simple stick. That is my finger. There we go. All right, now I am going to be wagging that finger from 1 inch from my nose to 17 inches. When my finger's away from my face the furthest, it's at 17 inches. Now, we're going to say that I complete a complete finger wag, like in 1 second. Out and back, it only takes 1 second for my hand to go away from my face and then back again. Every 1 second is a complete cycle. That was critical. So tell me, what's the equation for this? It goes between 1 and 17. All right, I saw this on some people's papers, and it made me, I had a little bit of joy. They made a little wave. And they said, okay, the low spot was where it was like 1 inch away from your face. And the high spot was where it was 17 inches away from your face. Okay. and then, but there's no times. So I'm going to tell you, it starts, my finger starts right by my face. Okay, so when I start this whole thing, my finger is 1 inch from my nose. So then this is really times 0, comma, it's 1 inch. And this is not time 1, comma 17. Think about it. What would it be? 1/2, comma 17. Half a second out, half a second back. That makes a complete cycle. Is 1. All right, so then y equals box, cosine box, parenthesis x minus box, parenthesis plus box. 4 boxes. Tommy, tell me one of my boxes.
It would be.
Would you start with the midline, actually? Can you tell me the midline? Have you done that yet?
8. 8.5.
All right. So tell me how you're thinking that through. Do you agree it's related to the 17 and the 1?
It would be 9.
Okay. I agree that the average of those two is 9. So this line is at 9. And then that means it's really how far up and how far down? Would this have to be 8 and 8? Does that make sense? Okay. There we go. So the midline's at 9. So where do I put that? Box 1, 2, 3, or 4? There's 9 here, Tommy. Where does that go? Box 1, 2, 3, or 4?
4.
Yep. That one goes in the last box right there. Yes? Okay. Let me double check that. Would you agree that the average of 17 and 1 is 9? Do you get that? I'm not saying that I couldn't be wrong on this, but would you agree that the average of 17 and 1 is it's 18, now 2 is 9. I think that's 9, isn't it?
Mm-hmm.
Okay. Now, this line that runs down the middle, let's just piece this together. What's the total distance between these two? Oh, I was thinking that it was 16 between those two. It is 16 between those two, isn't it? Okay, so then isn't it 8 each? Would you agree with all these assumptions? And if it starts at 1 at the lowest, and you add 8 to it, wouldn't it be 9? I'm pretty sure that dotted line down the middle is at 9. So you got 1 plus 8 makes the 9, plus another 8 makes the 17. I think it's all working. Okay, so if the midline's at 9, that goes at the end. And then I hope I drew the picture. It's like the definition of amplitude. It's from the midline up, which is 8. So that 8 goes there. And then, what's the period? Well, I made it really simple. 1. If the period's 1, period equals 2 pi over b. 1 equals 2 pi over b. B equals 2 pi. So I got to put 2 pi right there. I know some of you are thinking the period's 2 pi. No, the period's 1. All right, so then our b must be 2 pi. To make this really work, this would have to be a 2 pi, right? Because 2 pi over 2 pi would equal 1. So our b is 2 pi. And last but not least is the shift. The first peak was at 17 inches away from the nose. So that would be it. It's the x value of that, though. X value of that, which is right here. That goes there. And that's it. Time's up for the review. Any questions about that one? I will admit it even melted my brain for a minute about the midline on that thing. I don't know why it was so hard to do the midline on that. I think maybe it's because I started at 1. I think if I'd have gone like from 2 to 18, I think it would have been seemed easier for some reason. Because then there's all even numbers, so you know it's going to work out nice. I don't know. Okay. So that's a good review, including another way to think about those sinusoidal problems with the finger wagging back and forth. All right. And that's all I have for the video for today.